In this video, we are going to be comparing the memory efficiency of generators and slices in Golang. In the first video of this series, we talked about why generators are more memory efficient than in-memory containers like slices. Be sure to check out that video if you haven't yet already. In short, generators allow us to return values one at a time to their caller. You can imagine a case where a program needs to perform operations on a long list of data. Instead of the program having to wait for a function to perform an operation on each item in the list, it can get the result for one item at a time. Let's jump into VS Code. In our first example, we will create a function which creates a slice of course objects. The main program will call that function and perform an operation on each item in the slice. The program will then print the total memory allocation of the program to the console. Let's create the generate courses function. The generate courses function takes in an integer parameter which determines how many course objects will exist in the returned slice. Let's implement the rest of our function. Here we can see that we are appending a new course to the slice until it has the number of courses that the caller has specified. With our function complete, we can now implement our main function. In our main function, we are generating a slice with 1 million course objects and performing an operation on each. Let's now evaluate the total memory allocation for this program. We are now logging the total memory allocation in megabytes for before and after the courses slice was created. Let's also calculate the duration for generating the slice as well as the duration for operating on all course objects. With all of our logging in place, let's run the program in the terminal. It takes about 1.5 seconds to generate the slice, and the total memory allocation is over 2 gigabytes. The time for operating on all objects is negligible as it is so small. Let's implement this same program using a generator. Let's modify our generate courses function to return an iterator for the course type. Instead of appending to a slice, we can yield a course object back to the caller. Lastly, we have to fix our main program since the iter.seek type only returns one value. Let's run this program in the terminal. We can see from the output that it takes 0 seconds to generate the slice. This is misleading since we are no longer working with the slice. Let's fix this log. The return type of the generate courses function is an iterator of type course. So let's change this log to create iterator. Let's go back to the terminal. We can see that it takes 0 seconds to create the iterator, whereas before it took about 1.5 seconds to get a return value from the generate courses function. This is because our generator is not spending time creating 1 million objects and storing them in memory. Instead, it returns an iterator right away and waits for the caller to request the next course object. The time that it takes to perform an operation on each course object has increased. This is because the iterator has to create an object before giving it back to the caller. Whereas with the slice implementation, the object was already created by the time the program needed to perform the operation. Despite this increase in time, it is still so small that it is negligible. The most important statistic here is the huge reduction in memory allocation. We can see that the total memory allocation did not change. This is the power of generators in action. That's all for this video. If you found value in this lesson, be sure to like this video and subscribe to the channel for more Golang content. Thanks for watching.